Hello everyone. This is Dr. G. Anita Hebsiba, Department of Chemistry, Dr. S.N.S. Rajalakshmi College of Arts and Science, Coimbatore. We have been discussing about the different types of dyes, and in this video, our emphasis will be on acid dyes. What are acid dyes? Acid dyes are actually anionic dyes which are soluble in water and are essentially applied from an acidic bath. So the dyeing bath will contain some acids present in it and the pH should be maintained. These dyes possess an acidic groups such as sulfonilic acid group or carboxylic acid group, and they are applied on wool, silk and nylon, that is amide fibers, when ionic bond is established between the protonated amino group of the fiber and the acid group of the dye. So the interaction is between the amine group, that is a fiber which contains NH2 group, and the acid group of the dye NH2, that is it becomes NH3 plus, and the acid COO minus. So the interaction between the protonated and the acidic part of the dye. So acid dye stuff, they are called as acid dyes because the two main reasons. The first reason is they are applied from an acidic bath which contain either sulfuric acid, acetic acid or formic acid. And the second reason is they are actually sodium salts of organic acids. Hence, they get the name acid dyes. A common property of these dyes is the mechanism of interaction with the fiber polymers, which leads to strong binding of the dye to the material. The binding of the dye, at least partly, can be understood to follow an ion exchange mechanism. Ionic bonds are formed between, as I told you earlier, charged groups present in the fiber polymer and the charged distuff molecule. Here you see this is the amine group present in the wool, that is polyamide, and the acid group present in the distuff. So the interaction occurs between the protonated amine group and the acid present in the distuff. So the interaction is very strong. These dyes are important for coloration of protein fibers and polyamides which contain ammonium groups at low pH. Acid dye stuff. What are the properties of acid dyes? They are soluble in water, they are anionic in nature, and they are usually combined with basic dyes very easily because the interaction is very easy. These dyes are suitable for wool, silk, polyamide, and also for modified acrylics. Acid dyes have molecular weight in the range of 300 to 1000 gram per mole. These dyes are generally applied in the presence of acids like sulfuric acid, acetic acid or formic acid, sometimes very occasionally from a neutral pH bath. These dyes have no affinity for cotton cellulose, hence not suitable for cellulosics. They have substantivity towards protein and polyamide fibers alone. These dyes combine with the fiber by hydrogen bonds, van der Waals forces, or through ionic linkages, ensuring a very strong bond between the fiber and the dye. Now let us discuss about the classification of dyes. Acid dyes are classified according to their acidic nature. The first type of dye is neutral acid dyes. These are supramilling or as fast acid dyes. They have medium to good wet fastness properties. Some of the dyes have very poor light fastness in pale shades. When the pale shade, when you dye an acid, when you use an acid dye which is very pale shade, it may not exhibit a very good light fastness properties. Many of these dyes are used as self shades only, and these are applied to the fiber in a weakly acid or neutral pH. Weak acid dyes, these dyes belongs to the milling class of dyes, and they have good fastness properties, but light fastness is moderate to poor. Usually when you dye silk fiber and all, they are very much prone to fading when they are exposed to light. Strong acid dyes, these dyes are applied in a strongly acidic medium, and they are also called as leveling dyes. However, their wet fastness properties are limited. These dyes are very good to produce combination shades, and we very well know that acid dyes are applied from an acidic medium, hence the dye is dissolved in an acetic acid, and then we apply it by maintaining the pH at acidic pH. So we can just improve the light fastness by certain after treatment methods. Thank you.